So again, good morning. We are going to pick up where we left off in lesson 4. So just as a reminder of what we discussed in lesson 4, we talked about Boolean statements, right? Boolean statements and how to write Boolean expressions. We need to, in order to write Boolean expressions, we have to talk about these logical and relational operators, right? And so we looked at last class period, the relational operators and equality operators. We know how they work. The one that I emphasized last class period, and I don't want you to forget, and you're going to see this again. I do this because, again, I've taught this class forever, and I know if you're new to programming, sometimes this concept equal versus equal may confuse you. We will not be confused by these operators, right? They are not the same. So we talked about the differences between the two. The equal is what is a relational operator that evaluates to be either true or false. Equal is just an assignment statement. We put data in memory. Not, easy peasy. We're not going to get those confused ever again, right? Or ever. Right. Then we also looked at the logical operators, right? We introduced those logical operators, the and operator, the or operator, the exclusive or operator, as well as the not operator. We know how they work. We know the rules for each of those logical operators. The and operator, all must be true. The or operator, at least one must be true. And the exclusive or exactly one must be true. And of course, the not operator there means take the opposite truth value. All of those operators, we need to know those operators before we introduce, which we're going to do today, before we introduce the various types of branching statements that exist. And so that's what we're going to go over today. I will say this, again, we have a lot to cover in lesson 4. It has a lot in it. So I cannot emphasize enough, do not wait till the last minute to start going through start reading the assigned reading requirements, and as well as the complete those participation activities, challenges, and lab activities. There's quite a bit to discuss in lesson 4 and to look forward to. So the next thing that we're going to look at, so we looked at those relational, those logical operators. The next thing that we're going to talk about is this idea of what we call short circuit evaluation. And you can follow along with me in your lecture notes. And I made those available to you all, those lecture notes. All right. And so in our lecture notes, the last concept, and I'm in your part 1 of your lecture notes for lesson 4, if you choose to follow along. The next idea that we're going to talk about is what we call short circuit evaluation. So if you're joining me, we're picking up where we left off, which is what we call short circuit evaluation. So that's the third concept that we're going to look at. And so short circuit evaluation is the next thing that we're going to talk about. And when we say short circuit evaluation, this is how the computer, this allows the computer, and again, this is in your lecture notes. I'll just go back to your lecture, in your required reading, and in your required reading, you're going to see short circuit evaluation addressed in lesson 4.19, short circuit evaluation. Okay, I like to go over it here because we've just gone over our operators. And so again, I'm introducing you to the concepts you're going to read about for sure. So when you get to those concepts, you're not lost, right? You've seen some of these concepts before. And so here, what do we mean by short circuit evaluation? This allows the computer to quickly evaluate a Boolean expression. And so we definitely, again, you can follow along with me in lecture notes. I'm moving, again, I don't go slide by slide in the lecture notes. So you do really But those are for you to reference later, these notes if you need to. So here, what I do want to bring to your attention about short circuit evaluation is, first of all, the logical expressions are evaluated from left to right in that order. So from left to right, let's put that in there in our notes. Statements are evaluated from left to right. Okay, so that is an important idea. Another important idea with respect to short circuit evaluation is, when can the computer use short circuit evaluation? So when can the computer use short circuit evaluation? And that is what you need to be mindful of. The computer has an opportunity to use short circuit evaluation only when it encounters the following operators: the not, the and the or. So let's put that in our notes. So it can be used with the not operator, the and operator, and the or operator. Okay, so that's very important. And of course, there are other operators that we talked about and introduced last class period, but these are the main operators where short circuit evaluation can be used. So let's look at an example of, and we'll use our notes here. We're going to go through some examples of when short circuit and how short circuit evaluation takes place. First of all, we know you must appreciate the rules of each of these operators, right? And so first of all, we know the and operator. The rule for and operator says that all must be true in order for the expression to be true. Otherwise, the statement is false. We know that the or operator says at least one must be true. So keep those in mind when we look at these next examples and we determine whether the computer can use short circuit evaluation. Remember, we said that the computer uses short circuit evaluation, right? In order to speed up or save time in how it goes about executing or evaluating a Boolean expression. Okay, so with that being said, let's take a look at the following examples. So let's assume we have this variable called age and height. So these two variables are integers. Let's assume we initialize age to 25. We initialize height to 70. I need your participation here. So given the following expression, so age, if age is greater than 50 and height is greater than 60. So what do? We go to memory and fetch the current value of age. Age is 25. So 20 is 25 greater than 50? It is not. So because this expression is false, when we have a false with an and, what's a false with the and, you all? Go ahead and tell me that. What's a false with an and? Do we have to go over to this next expression and determine its truth value? Does everybody understand? Well, because we remember our short circuit evaluation evaluates from left to right, right, in that order. So because this expression is false with an and, do we have to come over here and evaluate this next expression? Do we have to? We know we don't, right? Does everybody understand why we don't? We do not, right? The computer does not. And why? So because of the definition, the rule for the and operator says that all must be true. Well, you've already determined that the first expression is false. So therefore, the entire expression is going to be false based off of the rule for the and operator. So the computer does not have to go over here and evaluate this next expression because it knows that the entire statement is going to be false. The entire expression is going to be false. So this is a scenario when the computer could take it could use short circuit evaluation. Thumbs up if that makes sense to you all. All right. And any questions over why we can use short circuit evaluation for this expression? Any questions? Are y'all with me? Let me tap the mic. Wake up. Are you all with me? Okay. All right, no questions. Let's go on to the next one. Let's hope this makes sense. So in age, we have and height. Let's assume we initialize age to 25. We initialize height to 70. Here I'm asking the question, is height, which is 70, is 70 greater than 60? Sure it is. So because this is true within the OR operator, do we have to come over here and evaluate this next expression? No, we do not. Why? Because of the definition of the rule for the OR operator. The OR operator says that at least one of them must be true. Well, the first one we evaluate is true. So guess what? All of the entire Boolean expression is going to evaluate to be true because of the rule for the OR operator. Right? We've satisfied the basic minimum, right, for the OR operator. At least one must be true. Okay, so we can use short circuit. The computer can use short circuit evaluation for this expression. Let's evaluate the next one. So in age, weight, and then we have it, we initialize age to 25. We initialize weight to 145. We're asking the question, is weight less than 180? So is 145 less than 180? Sure it is. That's true. So what's true with the AND operator? Can I use short circuit evaluation here, you all? Can I use short circuit evaluation? Here we have a true with an and. Can I use short circuit evaluation? If not, someone tell me why. You can tell me why. Why can the computer not use short circuit evaluation for this expression? If you say, that's if you say no. Why? No, because we have to check that both are true for the, yes, absolutely. Absolutely. High five, River. All right, so yes, because of the rule of the AND operator says that all must be true. So guess what? We have to continue to check until the very end, right? Because of the rule of the AND operator, all must be true. And so we don't have enough information to use short circuit evaluation for this statement. Very good. Awesome sauce. What about the following? And then we'll move on. So here we have age and height. Age equals 25, height equals 70. Here we have the not, but we have our parentheses. Remember, parentheses has the highest order of precedence, and so we have to evaluate the parentheses first. So is 70 greater than 60? Sure it is. So that's true. We take the not of that, that's false. So we have a false with the or. Do we have to come over here and evaluate this expression? We have a false with the or. We know that's going to be yes. I'm sorry, we can't, we do have to, the answer is yes, we do have to evaluate the next expression, which means we cannot, right? We cannot use short circuit evaluation. Very good, Anthony. We cannot use short circuit evaluation here because a false with an or, we have to check to see, because if age is greater than 50, it says it would still output false through though because false, both conditions are false. Yes, very good. Very good. But we still, so whatever the truth value of this second expression is, it's going to determine the truth value of the entire expression. Very good, because it's false here, the statement is going to be false, right? If it were true, then the statement would be true. Yes, very good. Awesome sauce, Anthony. Very good. All right. So that is short circuit evaluation. What I'd like to bring to your attention before we move any further is this slide. Okay, this slide. This slide tells the whole story about all of the operators that we've looked at thus far and where they are with respect to execution, right? The order of, or which ones have the highest precedence, meaning which ones will be executed first, all the way to the lowest precedence, which will be executed last. I hope this makes sense that, of course, anything that's inside of parentheses is going to execute first, right? We know that based off of, math, right? Basic math. And then the other operators you see, the not, the pre and post, and then we have a multiplication, division, and modulus, and then addition, subtraction. all of those relational operators that we just learned last class period, as well as equality operators. Then the logical operators are next to last. Okay, the logical operators are next to last. And why in the world would equal, the assignment operator, be very last, right? That is the last thing that we do. So think of it like this. Everything on the right-hand side of the assignment operator, of the equal operator, must take place and come up with a final value or result before we execute that assignment operator, which means put whatever was on the right-hand side of the assignment operator, put that value, the result, in memory, right? Which is the equal operator. Does everybody understand that? Okay, so the equal operator is the last thing that will take place because that's when we're going to put the final result in memory. Okay. All right. Very good. So that ends our part 1 of our discussion. And what I want, what you can do, you can easily see this is one of those programs that I've included in your code inspection folder. We can easily, let's do this real quick, if you would, please. Let's go to our code inspection folder and let's find this program called LeapYear, and let's put it in our programming environment, okay? So here's what I'm gonna do. I want you to get used to doing this. So where am I? I am in my, in the course website, and I'm gonna go to my modules page. And let's go, I'm gonna view as a student here. Hold on just a second so you can see. All right, so I'm going to scroll down to lesson 4 in my on my modules page, and I'm going to go to my code inspection folder. I'd like for you all to do this with me because, again, I want you to get in the habit of, I've given you some examples in your code inspection folder. Go ahead and click that folder. And there's a program that's called LeapYear, source code number 2. I'm simply going to download that. You can click on that download link there to the right of the name of the program. I'm going to open it up here. You can do several things here. So here's the program, LeapYear. What we can do, I'm going to right click my source folder, create a new program called LeapYear. And again, in your programming environment, I'm in IntelliJ. I'm going to create a new file there called LeapYear. What am I going to do? Highlight the code that I gave you, and then copy that into my new file here called LeapYear. I'm going to comment a few things here. This is the end of main, and then that last curly brace is the end of the class. Now, this is our program. Again, I give you these snippets of code. I give you these sample code in your code inspection folder for you just to understand and get it to reinforce some of the concepts that you learned in that particular lesson. And so here we see we have a program called, a class called LeapYear. Let's read it just for understanding here. And I'm also going to add some additional comments so that when you look at this code later, you'll be able to remind yourself of what you were doing. So here in this code, I've given you some comments, but let's add some additional comments. Here you can see we're creating a scanner object, That's what we're doing right here in this next line of code. What are we doing in this line of code here? I'm prompting the user to enter a year. So here, prompt user to enter a year. That's what I'm doing here. All right, what am I doing here? Here I am doing several things. And again, I'd like you to see that there's more than one way to write code, right? Coding and programming, you all, it's an artistic expression, meaning programmers are artists. And not every program or program looks the same, but it may, given the same input, get the same output. There's more than one way to code. All right, I could have created a space up top where I declared all of my variables, and then, but in this example, what am I doing? I'm doing two things here. I'm declaring variable year and initializing our year from user input. with user input, not with user input. Okay, that's what I'm doing is one line of code. I'm just, again, I want to make sure that you all need to know how to read code. Again, your exams are going to be like that. I am going to give you code, and I'm going to ask you to explain or tell me what the output is given the code that you see. Okay, so you need to be comfortable looking at code, okay, and tracing that code for understanding. And so that's what we're doing here. So what is these lines of code that you see right here? And you could put them on the same line if you'd like, or just put them on separate lines, but that's fine. I'll just, just so you can see this, they're the same. They're on one line of code there. So what is this line of code doing? It's checking to see if the year is a leap year, and it's using Boolean, using a Boolean expression, Boolean. That's what we're doing here. And so this is the equation that will determine whether the year that the user gives you, whether it is considered to be a leap year. So if you see here, according to the order of operation, right, we know that this is going to execute first. What's inside is going to execute first, and the order matters, right? You see that we have a modulus as well as logical operators, as well as the not. So you can see that this is going to calculate, and then this is going to calculate, and then the OR operator is going to execute to determine which one of these are satisfied or both satisfied. And if both are if at least one of these statements are satisfied, then it is considered a leap year, and the Boolean value is true. If both are false, right? If both are false, because we're using the OR operator, if both are false, then that year is considered not to be a leap year, and the is leap year Boolean value is assigned false. And so that whatever the value of that the user entered, along with whatever the result of calculating whether it's a leap year or not, is going to print to the screen. All right, so let's go ahead and now run this just to understand how this is written. And let's put in a leap year. You can enter any value that you like there. I'm just going to put this year in there, and it says that this year, 2025, is not a leap year. Right? We can evaluate it in many ways there. You can run it several times, given a set of inputs, or do you get the expected outputs? Okay. Any questions or concerns over this example? Yet again, this is why I need you to have a programming environment outside of your textbook, okay? So that we can practice, we can do code examples in class, and make sure that we understand the concepts. All right. All right, so with that being said, you can go ahead and close that output and close that program out. We're going to go on to the next topic. So you can follow along if you go to your modules page and go down to scroll to lesson 4. You can follow along. We are going to now look at part 2 of your lecture notes. So you can follow along with me. Part 2 of your lecture notes deals with branching statements, right? Your basic branching statements. So you can open that up and to follow along part 2. All right, so with that being said, let's go to our part 2 of our lecture notes. Just a second, sorry. All right, so any questions or concerns before we move on? None? If there are none, let's jump right on in to our next conversation, our next topic. In our next topic, we're going to look at the different types of control statements that exist. And so we're going to pick up where we left off in our notes as well, and continue this discussion. All right, so the next thing we're going to talk about is right, conditional or branching statements. That's the next conversation that we're going to have. So what are conditional statements and branching statements, and when in the world would we use them? Okay, when in the world would we use them? So let me just, and I love this diagram, and I pick these pictures on purpose because, again, I'm a visual learner, right? I can, this really does kind of depict these images that you see here, depict the types of programs that you've seen thus far and that we potentially will see going forward, okay? So look, if you notice this first diagram here, it's just a straight road down there's no, veering off or anything. This is an example of the types of programs that you've seen thus far. We call, you see them, what does this depict? This depicts those sequential, so programs that execute each line of code one after the other. That's what you've been writing thus far. Every line of code is going to execute, of course, not your comments and blank lines and all that kind of stuff, right? But the programs that you've seen and written thus far, every single line of code is going, or statement is going to execute one after the other, right? Every single line of code is going to execute one after the other. Well, we're going to now look at some statements that look like the following, kind of mimic the following diagram that you see there. Is that from here, we're introducing, remember, I'm like your Vanna White. I'm showing you these tools that you have in your tool belt that you can introduce whenever you need to, based off of the problem that you're trying to solve. And so you may be trying to solve a problem that may need what we call a conditional or branching statement, right? Meaning that you may need to introduce code where not every single line of code will execute. It depends on some condition, whether a line of code executes or not. And so this is an example of that diagram that you see there, based off of so you're driving down the road, and based off of some condition, meaning the truth value of some Boolean expression, it will determine whether you go to the left or go to the right. So based off of some condition determines which code is going to execute next. Does everybody kind of can you visualize that? That is when you would want to potentially introduce what we call a branching statement or a conditional statement, okay? And so let's look at, in the next discussion, or the discussion we're going to have for the remaining of class, is the types of conditional statements that are recognized in the Java language and in other languages, right? Remember, what I'm teaching you will assist you and help you learn and pick up other languages, right? Because these ideas, these concepts are in other languages. They just syntax may be slightly different, but the idea of a conditional statement and branching statement exists in other languages. And so here are the basic conditional statements that are recognized in Java. We have the standalone if statement, right? And so let me just put this here to continue our topic. So here, this is conditional statements are statements that allows the computer to determine which statements or lines of code statements will execute. Sorry, execute based on the condition, on some condition or Boolean expression. Okay, just a simple statement there about what is a Boolean, what is a condition or branching statement. And so here, what is the idea is that not every statement, not every line of code will execute in a program when conditional statements are included. Okay, so that's kind of the idea, and I just wanted to, I just want to make sure that we're comfortable with and we understand, like, when are these conditional statements included, or when are they used, how are they used. And so here there are three types of conditional statements that exist. And so with that being said, there are three types of conditional or branching statements. And we're going to take a look at those right now. The first one that we want to take that we see is what we call an if statement, or may also be called a standalone, okay, if statement, okay, a standalone statement. And so these are the three that we're going to take a look at. So the standalone if statement, the if else statement, or bidirectional or two-way branching statement, rather, and a multi-way branching statement. Okay, so the first one that we're going to take a look at is what we call a standalone statement, a standalone if statement. And so here is the syntax that we need to be mindful of. And we looked at the standalone if statement last class period. I kind of introduced it ahead of time. And so here is the syntax. We have the word if, the keyword if, and what always follows the keyword if is our Boolean expression. And what always follows that, well, not always, I should not say always, what could follow that, and I'll explain why I say it could, is the open and close curly brace. And what always is inside, when it's inside or associated with the standalone if statement, would represent one or more lines of code, okay, that are associated with the if statement. Okay, I'm going to put a little note here for you all, and here's why I say that it may or may not include the open and close curly brace. I want to make a note. You should see it in your lecture notes as well. But those open and closing curly braces, let's talk about this really quickly. And these open and close curly braces are optional. No, if there is only one line of code associated with the if statement. Now I want to put this in here because now, and this applies not only to the if statement, I'm talking about it right now with the if statement, but I want you to appreciate that the open and close curly braces are optional whenever we have one line of code that's associated with whatever that statement is, whether it's the if statement or the else statement or a loop when we go to lesson 5. But if you only have one line of code that's associated with the if clause and even the else clause, the curly braces are optional. I don't encourage you to omit the open and close curly braces because it's easy for you to see who belongs to who. But your computer will assume that if you omit the open and close curly braces, that you only have one line of code that's associated with whatever that clause is, whatever that statement is. Okay, and again, we're going to talk more, and we're going to look at this this idea going forward for sure. But just in case you see code, you're reading through code, and they omit the open and close curly braces, I don't want you to panic, but I do want you to think like a computer. A computer, if you omit those symbols, it's going to automatically assume there's only one line associated with that if statement or that else statement or whatever the statement is. Okay. All right. Let's look at some examples of, if we would, in our code here, in our statement here. So for instance, if you see here, look at this, this example that you see off to the right-hand side. You see there's our standalone, there's our reserved word if. What always, now get this in your brain, what always follows the key word, the reserved word if is a condition, a Boolean expression. I cannot emphasize it enough. Anytime you use that keyword if, the computer is going to automatically look for you to have a Boolean expression right after it and enclosed in parentheses. So here it's asking the question. So if 5 is greater than 4, then what? So if this condition is true, if this Boolean condition is true, you're given permission to come inside and execute what's inside of these open and closed curly braces. What do we know those open and closed curly braces are? We talked about them weeks ago. That's a block of code. Open and closing curly braces indicate to the computer that you have a block of code. A block of code represents one or more lines of code that are grouped together, right? That are grouped together. And so that's what that's an indication to the computer. Those symbols mean something special to the computer. So if this condition is true, come inside this block of code and execute these one or more lines of code, which here you see just two print statements. Do you see that there's an indentation here as well? Remember, indentions and blank lines are ignored by the computer. They really could be flushed to the left margin, but we use indentions so that we can easily see, the user or programmer can easily see who belongs to who. Those curly braces tell the computer who belongs to who, but indentions really are indication to humans, right? And are helpful hints to humans that these lines of code or block of these lines of code belong to the if statement, okay? But they're not indication to the computer. Those indentions are not for computer use, but for human use. And so you see here this statement, this system.out.println statement, I will always print, does not belong. It is not controlled by the standalone if statement. It is outside. So it's going to execute no matter what the truth value is of this condition. I hope that you all can see that. Okay. Let's look at the next statement here. And those are standalone statements here. And you can see some other examples. I talk about indentions and I talk about the importance of being consistent. I cannot emphasize that enough. And again, these slides are for you. You can read them as you see fit. I want us to look at this next program that's in your code inspection folder called SimpleIfDemo. So SimpleIfDemo, let's go ahead and take a look at that, if you would please. Go to your course website and let's go to our simple if. So we're going to go back here and I'll go to our code inspection folder for lesson 4. And I want you to bring it into your programming environment, if you would, please. It's called SimpleIfDemo. It's your code inspection code 3. Go ahead and download that. Let's open that up, if you would, please. And let's go ahead and create a new file called SimpleIfDemo. And I'm going to simply copy and paste that code into my programming environment. I hope you all are following along and doing. Remember, this is not a lecture and, no, this is a learn by doing class. So let's go ahead and do this. We've got to comment our codes and curly brace here. This is the end of main. And then this is the end of our class. Okay. I'm going to comment. So you all comment your code as well. I left off comments intentionally because I like to do them with you in class. So you get used to doing these things on your own. You get used to writing the code, but using good documentation, use good spacing, use good indentions. This is what I'm demonstrating. Not only am I demonstrating these concepts, but also programming style and documentation and the things you need to be doing when you're working on your own. So here, what am I doing in this next line of code? I am create the scanner object. What I'm doing here in this next line of code, right? There's my object called input. In your textbook, they use the word SCNR. They mean the same thing. It's just, remember, those are user defined. The scanner object name is user defined. What am I doing here in this next line of code? I'm prompting the user. So prompt user to enter an integer. Okay, enter an integer. That's what I'm doing right there. What is this next line doing? I am reading. See what I have highlighted? I'm grabbing or reading the next integer from the input stream. Whatever the integer that the user typed in, I'm grabbing that value, retrieving it from the input stream, and I'm storing it into this variable called number that I'm declaring. So I'm initializing here, declaring and initializing. So declare and initialize okay? Or using user input, okay? You're declare and initialize number using the user input, okay? That's what I'm doing in this one. Remember, this is done in 2 steps. It's declaring that variable, meaning reserving 4 bytes in memory for the variable call number, and then it retrieves that value from memory and stores it in the variable call num. That's because I'm declaring and initializing in the same step. Now what I'm doing, and I like this example because this ties in a lot of the concepts that, and remember, your exam 1 is going to cover lessons 2 through 4. That means those operators, all those logical operators, the branching statements, conditional statements, all of those things that we've gone over thus far. So this really, what am I doing in this next line of code? I am evaluating whether the value that the user entered from the keyboard, whether it is a what? Anybody have a clue what, if I say number mod 5, if it's equivalent to 0, come in here and print high 5. What am I doing here in this standalone if statement? What do you think? What is this statement looking? If it's divisible, exactly, River. If it's divisible by 5 or multiple of 5, right? Multiple of 5. Is everybody with me on that? That's what this statement is saying. Is number divisible or multiple of 5? That's what this is checking for. And if it is, come inside and print high 5. That's what this standalone if statement is doing. Is it a multiple of 5, right? Or divisible of 5, okay? And so, do you notice that the open and close parentheses, curly braces are left off, right? Because there's only one line of code that's controlled by this if statement, or this if clause. You'll hear me say that. This is what we call the if statement, or this is the if clause of the if statement. Okay. What are we doing in this next line? We're checking to see, right? Is number divisible or multiple of 2? Which means that it's even, right? It's even. That's what we're checking, and that's what this condition is doing. Please get used to saying this. If it's even, here's where I'm checking to see whether that value that the user typed in is even. Because if it is even, and if I divide it by 2, it should give me 0. It should be equivalent to 0. All right, the remainder should be 0. So if it is a multiple of 2 or even or divisible by 2, we're going to print high even to the screen. So let's go ahead and run this code. And here put in any value and test it. And do you notice I put in 99? Look what I did. I put in 99. So what is it going to do? I want you to be mindful of this, because we're going to talk about two-way branching statements. And so here, I want you to appreciate that this condition is going to be checked. It's asking, is 99 mod 5, is it equivalent to 0? It's not. So therefore, high 5 did not print to the screen. And then it comes here and also checks. Also, these statements do not belong to each other. These standalone if statements are not associated with each other at all. They're going to execute individually. That's very important. And so what is going to happen here? It's going to also come here and say, is 99 mod 2, is it equivalent to 0? It is not. So high even does not print to the screen as well. So it's not a multiple of 5, nor is it a multiple of 2. Run the program one more time. This is what we call testing the program. Give me a set of inputs. Do I get the expected outputs? Let's now put in another value. I'm going to put in 28 and type and push enter on the keyboard. And you see that high even did print, but high 5 did not, because 28 is not a multiple of 5. So it did not print. But that second standalone if statement, the condition was satisfied, and thus the print statement, print high five to the screen. All right, so I hope that makes sense to you. Questions or concerns for me to address? Any questions or concerns? All right, so if not, let's keep rocking and rolling. So with that being said, all right, we have our standalone if statement. The next statement, or the next type of branching statement that we're going to look at is what we call the if-else statement. The if-else statement. We also call it a two-way branching statement. So we're going to look at that next. And so the second type of branching statement that we're going to look at is what we call an if-else statement, which is what we call a two-way branching statement. Okay, a two-way branching statement. So a two-way branching statement, what do we need to be mindful of? A two-way branching statement. Here is the syntax for a two-way branching statement. A two-way branching statement looks like the following. So the keyword if, then we have some Boolean expression. Then we have our open and our close curly brace. And let me just set it up first. So then we have an else, a keyword or reserve word else. Then another open and close curly brace, right? What goes inside of the if clause? We call this our if clause because it's inside of that open and close, the first open and close curly brace. This is what we call, this is our if clause. This is what's going to execute if the condition is true, okay? Inside of our else clause, this is what's going to execute if the condition is false. I'm going to say here condition. And this is the if clause. I'm going to say executes. And say that as well for this one, executes. So I hope this makes sense to you all. So you see that we have what we call an if clause and an else clause. When will the if clause when will the if clause when will the statements that are associated with the if clause execute when the condition is true? When would the statements that are associated with the else clause execute when the condition is false? Okay, executes when the condition is false. All right. Questions or concerns so far? So let's take a look at some examples of the if-else statement, which is it's called two-way branching statement, a two-way branching statement. With the two-way branching statement here, you see in this example, so if 5 is greater than 4, then come inside and print this statement to the screen. Else, come inside and print this statement to the screen. So you can see examples here, see everything spelled out. Remember this, you all. Those curly braces are optional. If you only have one line of code that's associated with the if clause, or only one line of code that's associated with the else clause, you can omit those open and close curly braces. The computer will know, not that it will know automatically to only look at that the condition only controls the next line of code, okay? Or that statement, that clause is only controlled by the next line of code. So again, those curly braces are optional, and I demonstrate that in your lecture notes as you see here. Let's look at the next example that you see right here. Int grade is equivalent, initializing grade to 50. If grade is greater than or equal to 60, come here and print pass, else print failed. And then you see here system.out print line ln end exclamation point. So you can see that based off of the condition, it will determine which code is executed next. And this is what I meant by when we introduce branching statements or conditional statements, you're adding a little complexity you're adding some more complexity to your program. I mean, the computer has to do a little more work versus when we just have sequential statements where every line of code is going to execute. When we introduce branching statements, not every line of code is going to execute. The computer has to evaluate conditions to determine which code is executed, okay? Which one or more lines of code are executed. So you can see. So here's an example of where we I want to, we looked at early on in the semester, we looked at this idea of calculating the pay for employees. Remember, in that example, we looked at how do we calculate the pay for employees that look like Alice, and how do we calculate employees that look like Bob. Remember, Alice works less than or equal to 40 hours, right? And Bob represents those employees that worked over 40 hours, right? Overtime pay. If you all recall that example where we went over in class, and here's just a depiction of that idea, is that if the hours is less than 40, which represents those employees that look like Alice, then this is how we're going to calculate the rate of pay, right? The pay rate, which is pay equals rate times hours. Otherwise, then that means otherwise we're talking about Bob, those that look like Bob, those that worked overtime. Otherwise, this is how I'm going to calculate the pay. And in order to calculate the pay, you have to think about, as you're designing your branching statement, you have to think about what's going to control how I calculate pay. It's all based on the number of hours they work, that employee's number of hours they work. Does everybody see that? Okay, based on their hours. So let's look at how, does everybody understand this example? Yes, okay. And so it would be if you would introduce an if-else statement for a problem like this for sure. So what about this next idea here, you all? Let's look at this next idea. In this diagram, you see that we have cars, we have driver age, we have our variable called premium and monthly payment. Those are floating point numbers. So here, look at the condition here. In this condition, you can see we have two conditions. And then here inside, we have two statements that are controlled by the if clause, and then two statements that are controlled by the else clause, right? And so can someone tell me based off of this condition, give me the English translation, right? So that someone who does not know how to code, tell me what you think this means in terms of cars and insurance and things of that nature. What do you think this condition is saying in English? This condition, and given what you see inside of the body of this if clause. Can someone translate that for me? What do you think it's saying? You can unmute yourselves or put it in the chat. What do you think it's saying? Think about in everyday life.
Is it saying that if the car has 4 doors and the driver's age exceeds 24, that the premium cost is $650?
Absolutely, absolutely. And that means that they're at low risk, right? So if they're greater than 24, they're older, and they have a safe car, like a four door car, they're safe. Yes, and I'm looking at the chats. Excellent, you all. And the else clause says otherwise. So what would make me execute the otherwise? One or more of these conditions, or both of these conditions have to be false. Which ones? Right? One or more of these conditions, or both of these conditions have to be false. Both have to be false, right? That means that they're driving a fast, sports car with 2 doors, or a motorcycle. Goodness, a motorcycle, and they're old and they're younger than 24. They are at risk. They are high risk. That means your premium is going to be more. Your interest is going to be more. Does that make sense, you all? Okay. Again, what determines, and that's what I want you to be mindful of, is what helps you determine how to calculate or what the premium should be. It's based off of the number of cars, the number of doors, as well as the driver's age. That's what determines, right, how to calculate the premium, right? What the premium rather should be. So once I determine what the premium should be, then I can calculate their monthly payment. I'll now know what the premium is, and I can use that in my equation to calculate the monthly pay. Does that make sense, everybody? And so this tells you, so you've got to know when. Remember, I'm just here to show you and to demonstrate to you the tools you have in your tool bag. It's up to you to determine which tool to use, right? When you need to introduce these concepts in order to solve the problem. I need to introduce that two-way branching statement because I have two options. The premium can be calculated. The premium will be $650 if this is the case, or the premium will be this if the scenario, if this is the scenario. So you only have two premium values, right? So which means you would based off of some condition. So that means I need to introduce a two-way branching statement. If I have more values that I could assign premium, then I may need a multi-way branching statement, which is what I'll introduce to you on Tuesday on Tuesday's class. There are two types of multi-way branching statements that that we may need to introduce. So that's two-way branching statements, you all. And that any questions over two-way branching statements or how to use a standalone if statement or a if-else statement? No. All right. So here is where I'm going to break away, you all. And I'll have a end of class reflection that I would like for you to complete. Okay. And give me just a second and it'll be ready for you all. It's just 4 little questions that I want you to answer. Give me just a second. I apologize. Shouldn't take you long. Why is this not coming out right? Oh, I see why. Sorry. Do you all see that? Let's see. Do you see the assignment in your quiz area? Did you see it for today? Okay. Very good. So here is I don't know why it's taking so long. Come on, come on. Always something. Okay, so here is the code in your chat. You can also see it right here as well. And just a few questions, 4 questions, little simple questions that I'd like for you to answer. You can finish those questions and you are done for today's class. Okay. And so